Hello again from CodeWord. I am Samir Mistry and this is calculator part 3. Hopefully the final part of calculator, and then we can move on to some other exciting things. As you can see, we are on a new kind of setup here, and font size is definitely increased as per your requirement. Viewers have been complaining about it for a while. So we are in a new environment, and I'll talk more about the setup at the end of the video, so stick around. For now, let's just concentrate on the program. We can run the program directly from here. This is, as you can see, cargo run. Let's run the program then. It is taking its time. Compile and then run it. Okay, here we are. I'll do addition 10 and 20. Perfect, the program works. Run again. Subtraction 20 minus 10, 10. Perfect. Run the program again. Multiplication 10 into 10, 100. Perfect. Run the program again. Division 100 by 2, that is 50. Perfect. I think you get the point. We need to run the calculator again and again and again to perform another operation, which is quite inconvenient as humans we don't really like repetitive tasks. What we can do about it? Well, we can apply something called a loop. A loop is something which repeats the code in it for a certain amount of time. How many amount of time we will be seeing when we see different types of loops. But the most basic type of loop in Rust is just called loop. Okay, loop. And followed by a block of code. We're going to take all this code and then cut and paste it because we want to repeat all of the code. And that's it. Our code should start repeating now. Let's run. Addition 10 and 20. Perfect. The result is 30 and our menu is again printed. Subtraction 30 minus 10, that is 20. The result is here and then the menu is again printed. Multiplication 10 into 20, that is 200 definitely. Now I think I'm done with the operations, and how do I exit? There is no option to exit. Proficient Linux users might know that Control C would just break the program and show me the prompt again. Another way to break the program is to just provide anything other than a number, which will then throw an exception and the program will exit. But none of them is a graceful way to handle exit of program. Let's provide another option for it rather than. Println fifth choice exit, and then we need to actually handle the choice. So whenever you come here, whenever the choice is entered, we're going to just exit the program if required. We'll check if choice is 5. Then we want to exit the program. But how do we exit the program? To exit the program, we need to exit the loop, because after the loop, this bracket is for the end of the loop, after the loop we have not written anything. To exit out of a loop, we have break keyword. What break keyword does is it actually exits from the loop without executing any of the further code, and then starts executing the code at the next line after end of the loop. But as you can see, there is no next line after the end of the loop, so the program will definitely exit. Let's see. Oh, I forgot to print the choice actually. No, I did. Oh, I haven't saved the file. Okay, perfect. 10 and 20, the result is 30. Multiplication 30 with 20, 600. Let's see. Now I want to exit the program. Perfect. The program exited really gracefully. Now I'll take this opportunity to also clear up the flow of program. As you can see, we have this funky flaw in the program that if someone enters like 100 choice, then the program goes ahead and then asks for first operand and then second operand, and then we go ahead and say that yeah, the choice wasn't correct and you need to start again. But if the user chooses another inappropriate number, then it should be telling the user right away that the choice is not correct. We'll do it here. If choice is less than, damn you atom, 1, or choice is greater than 5, then we don't know how to handle this thing. So what we will do is we will just tell the user that whatever entered was not correct, and just go back and take another choice. The choice was inappropriate. Please choose something from menu. Perfect. I think some plugin is slowing my atom down significantly. I'll see about that. And then we're going to use continue. Continue keyword helps us move to the start of the loop without executing the rest of the code. So whenever the execution flow comes here at continue statement, it will directly jump to the start of the loop without executing any of this code, which is convenient for us. Save the file. Let's drag in 1, 10, 20. Result is 30. Perfect. Now let's enter 100. Yes, the choice was inappropriate. Please choose something from menu. Seems to work really well. Let's exit the program. Now some of you might have guessed that I am quite with the concept of user interface development and good user interface design. There is no user interface in the program, I understand that, but we can just provide a good user experience here. The problem here right now is that whenever we run the program 1, 10, 20, and then the menu is printed directly below our previous choice, our previous result, which is quite annoying to me. For some of you it might be just fine, but it's quite annoying to me, and we can actually get lost in this bunch of text and can find the result after the operation, which is not really good design. Let's see again. 10 and 10. The result is 100. The result is 100. This line is like tucked away in this whole mess of text, which is not good because the result is an important part of the output. Can we do better? Yes, we can. Most of you should be aware of the clear screen construct provided by C language in Windows. There is no clear screen in Linux, but we have curses library for C. The unfortunate thing is there is no official way to clear screen in Rust, and there is no external packages that should work as expected. So we'll have to invent our own clear screen for now. To invent our own clear screen, what we're going to do is, let's say, there are many methods. You can do some clever tricks with sending ASCII numbers using println to clear the screen, but that is not guaranteed to be platform independent and is not guaranteed to work on all kind of terminals. And another dimension that I'd like to add to this problem is that your users were not always going to be local. I started to think about it really recently that your users might be coming from another computer by doing telnet. So we need to think about that users too, and those ASCII characters that you are sending from here might not be valid on the screen there. There should be another operating system or whatever. So there is not a foolproof way to handle screen clear. The other easy solution that I can think of is to just spawn another process and then let that process do our work for us, which is clearing the screen. What we can do is we create a new process, we tell it to clear the screen, and then the process comes back with the result. We can do something like that in Rust using a process module, which helps us communicate with other processes and ourselves, and the command struct, which can be used to have a fine-grained control over how and what the command process is executing. Let's see that. So standard library, process module, and command struct. Command is a struct. Structures will be covered in a later session, so hang tight for that. There is an associated method new on it, which will create a new value of command. We are going to pass the clear method or process name as the argument. As clear is available in the OS path variable, we will not provide the whole path to clear, only clear is sufficient. Now the command up to this will just create a new command value, and it will not execute the process. If we call status on it, it will create a new process, it will run the command, and then it will return a result to us. As you might guess, the result object is the result value, which we are getting as an error or OK message. So we need to handle it definitely. Now we're not going to talk about handling it right now. Let's just crash the program if anything bad goes. It should clear the screen, definitely. And let's try to run the program and see if it actually clears the screen. So run it. Okay, seems to be working. 10 and 20. The result is 30. Whoa, why did it not clear the screen? Let's try again. Subtraction, 20, 30. Okay, it did this time. Addition, 10 and 20. It did again. Multiplication, 10 and 30. Okay, sometimes it is not working, but I think I have the best route as this only. We can do much about clearing the screen because there is no official way to do it. Okay, this seems to work reasonably fine for our use case. Now what you want to do is, there is a problem. If you didn't notice, let me show you. One is addition, 10 and 20. As you can see, we can't see our result. Our result just cleared. Why would that be? Now what the problem in this code is, whenever we give input and the flow comes here, it calculates the result and then it prints the result. Then after printing the result, the flow directly moves to the start of the loop. It clears the screen, it prints the menu, and then it waits for our input without ever asking for the choice that if we have seen the input or not. And it happens so fast that we cannot even see the input. The solution is getch in C terms, but this is not C language, and we don't have getch in Linux, even in C. We need to create our own getch here because there is no other official function to do that. To create our own getch, what we can do is we can take some input and then just ignore it, whatever the input was. What we can do is IO standard input dot read line. We pass immutable string, and then if it fails, we don't worry about it. Let's try this one. Okay, what's wrong? Sorry. Oh yes, this is not a function call, this is an associated method. Run the program again. Yes, we can see addition, 10 and 20. The result is 30. Yes, and it is waiting for our input. Now if I hit enter, it will just print another menu and we are ready for another operation. 20, 10. The result is 10. Perfect. And if I hit enter, it is going to print it again. Multiplication, 10, 20. The result is 200. Perfect. And let's exit. Now, one other problem in this program is that if we can't clear the screen, if there is an error somewhere in the clear command, then because of the result object and the expect call, what we are going to do is that we will just crash the program. But that is definitely not what we want. Even if we can't clear the screen, the calculator can work just fine. Here I am going to show you how you can convert an expect call to handling the error yourselves. What we are going to do is we will remove the expect call. Then we will enclose this whole expression which is throwing a result value return in a match expression. We will put match and then block around it. Now this is where the match expression shines over switch case. Switch case can work with direct values which can be matched with is equal to operator. But coming to match expression is actually using patterns. Now pattern is a really wide topic, and other languages are also moving in the same direction to include patterns in their flow. I think Java is doing it with Project Amber to include patterns language wide. I don't know, I'm not sure about that, but I'll probably make a video on that. Now what patterns are is they can really match any object along with the values. So what is returned is a result value. A result value can be of two types, an OK value or an error value. We can match both of them using match expression as cases in a switch case. If OK is returned, this case will be executed, and if error is returned, this case will be executed. Now the parameter in OK is the result of the process if the process executed perfectly, and this n would mostly be a return code which was returned by the process, and error contains more information about error in the e value. This e value would be returned by the OS, and we don't want to do anything in both the cases. We can put semicolon here because it requires statements. And now, as a challenge, what I want you to do is use this match expression trick and replace every expect call in the program by handling the error and showing a meaningful error message. Now we'll just check the program if it is working correctly. Okay, something is wrong with the program. Println, what is wrong? Unreachable statement. Why is it unreachable? Oh, okay, forgot the comma there to separate the cases. Try again. Okay, it is working. You might have seen some error, actually not error, a warning before the program cleared the screen. I'll tell you what it is, but first just let's run the program. 10 and 20, the result is 30. Definitely it is working. 20 minus 100, negative 80, it works. Let's exit the program. Now why the warning appeared is because we are not using this n and e anywhere on our program, so they are kind of unused variables, and Rust is complaining about that. What we are going to do is we can replace them with underscore to show the language that we are not using them and we don't care about them. It is not necessary, it is just a warning, but your program should not have any warnings and errors. Warnings are not useless. Let's run the program again. Okay, no warnings this time. Addition 10 and 20. Perfect. Exit and close it. And I think we came to an end of our calculator journey. It has been a good one. We learned a lot and it was a mouthful of information actually. Now you will not really know how to make the calculator in Rust by me making it. You have to make it by using the videos. If you don't make the calculator for yourself, by yourself, then I don't think you will be getting a good programming knowledge. People say that math is not a spectator sport. What I say is coding is not a spectator sport. Oh, I think I invented a new quote just now. You can spread the quote and just don't forget to quote me below it. If you don't really work with the calculator and build it for yourself, then you will not be good at it. Being good at something such as programming requires a lot of practice and a lot of repetitive tasks and a lot of debugging and a lot many things, but you are just going to make the calculator right now. Start small and then we'll move on to bigger projects. You can just watch the videos again, all 3 of them, and learn the topics again and just try to make the calculator for yourself. I assure you that you will feel accomplished after making the calculator. And that's it. And yeah, totally forgot to tell you about the new setup. We are using Atom Editor or Atom IDE here, whatever you want to call it. And the plugin I'm using is, let's see, Tokamak. I forgot the name. Tokamak is the plugin that I'm using. I'm going to link it in the description, or if you go to Google and type Tokamak Rust Reactor or Fusion Reactor, I don't remember, Fusion Reactor plugin, then you'll find it. It is quite famous actually. And if you're not using Atom and if you're using Sublime, then we just released a video on a few awesome Sublime plugins which you should definitely check out. See you in the next one. If you liked the video, please hit the thumbs up button, subscribe to my channel and share this video to all of your friends. Peace.